Hi, my name is Rhythm. I am a Senior Solutions Architect here at AWS, specializing in Fintech, and we are so glad to have you joining us today in this year's ASEAN Summit. This particular session, From Data to Insights, How Fintech Startups Are Leveraging Analytics Services on AWS, is intended as an introduction to how startups in different sub-verticals of Fintech are building their data analytics workflows on AWS, as well as hear from one of our customers on how they are using Amazon EMR for their analytics workload. Without further ado, let's get started. First, we will see why having a data strategy is so important for Fintech startups. Then we'll move on to the different sub-verticals within Fintech and see how startups operating in those verticals are thinking about data. Companies operating in the Fintech and financial services industry space deal with high volumes of data every day, from transaction history to market information. Fintech startups need to break down data silos and turn their raw data into insights in the drive to bring innovation to digital finance and address customers' needs in real time. Having access to alternative datasets, conducting advanced analytics, and drawing intelligence from them are also the key differentiators for fintechs when compared to traditional financial services. The flexible nature and faster technology adoption of fintechs have allowed them to take market share from incumbents and truly personalize the end-user experience. Given the data sensitivity and regulatory landscapes, fintechs must do all this while juggling stringent security and compliance requirements, and staying agile, flexible, and cost-effective in their data strategy. When it comes to data, fintech customers want to discover and have access to valuable third-party datasets easily. They want to have a unified store to manage a variety of data sources while maintaining security and compliance posture in alignment with regulations. They also want to protect PII data privacy and manage data both in transit and at rest. They want to analyze data in a variety of ways to get smarter, deeper insights in real time, and also scale with high agility and low costs. Data lakes can help fintechs achieve these above goals and effectively turn their data into insights. 4 benefits for building a data lake include: number 1, consolidate multiple silos or types of data into a single resilient, cost-effective, secure, and scalable storage platform. Number 2, deploy, secure, and govern their data repositories quickly. Number 3, enable BI and analytics professionals to get access to the tools they need to turn data into business insights. And lastly, discover, catalog, and prepare data for advanced analytics using machine learning. There are many benefits of building a data lake on AWS. Top differentiators include: number 1, you get unmatched durability, scalability, and availability. Amazon S3 provides the best possible storage layer for a data lake, with 11 nines of durability, a highly resilient 3 availability zone architecture, more regional replication options, and the ability to separate and independently scale storage and compute. Number 2, more ways to optimize costs. Amazon S3 provides more storage tiers than any other cloud providers, including S3 Intelligent Tiering, which automatically moves data between storage tiers based on how the data is being accessed. Glacier Deep Archive provides exceptionally cost-effective long-term data retention and is leveraged by global financial services of all sizes in complying with regulatory requirements. Number 3, best security compliance and audit capabilities. Amazon S3 is highly secure. The combination of AWS IAM, Glue, and lake formation provides granular data and metadata access controls. Amazon S3 block public access ensures that data can't be inadvertently publicly exposed. Amazon S3 is the only storage service that lets customers see every API access to data and management events. It is also the only storage service that integrates with a service like Amazon Messi, which uses machine learning to help customers better manage users' sensitive PII and financial data. And lastly, broadest and deepest capabilities for a data lake ecosystem and downstream analytics opportunities. AWS offers 100+ services to support any data lake use cases. AWS has the broadest and deepest set of machine learning tools for downstream analytics opportunities, where we aim to put ML in the hands of every developer and data scientists. AWS also offers the most complete marketplace of third-party ISV partners and datasets specific to fintech and finserv use cases, giving customers the freedom of choice to leverage their existing preferred relationships. First, let's look at how digital banks are using data to transform consumer banking. From stopping fraudulent transactions to providing customers with data for informed financial decisions, These banks are leveraging the depth and breadth of AWS data, analytics, and machine learning services. Shortly after launching, Australian fintech Hey observed a high rate of user drop-offs within a few days of retail users downloading the app. By using Amazon EMR in conjunction with third-party tools, the company was able to process and visualize target customer data to address issues and adjust the user experience accordingly. Within a week and a half of testing and making changes, Hey had increased conversion rates for new users by 300%. They also integrated their ML-based risk management solution, which prevents fraudulent transactions from completing, with their single pane of glass operational platform, where those transactions are flagged for investigations powered by Amazon Athena. In the open banking space, an AWS data lake makes it easy for fintech startups to discover, manage, and analyze a variety of financial and customer data in the open API ecosystem. AWS Analytics Solutions enable fintechs to extract deeper, more sophisticated insights from this data to provide better, more personalized products and services. In the capital market space, companies are leveraging AWS data lakes to conduct market surveillance and financial analytics. The scale and agility of AWS data lakes makes it easy to aggregate data from multiple sources and conduct large-scale data analytics such as backtesting trading, investment strategies, and identifying market trends and opportunities. We see that trend wherein more and more companies are using a serverless-first approach to data analytics. The Financial Industry Regulatory Authority, or FINRA, which is a not-for-profit organization authorized by the US Congress to protect investors and ensure market integrity through effective and efficient regulation of broker-dealers, oversees up to 75 billion market events. That's 99% of equities trades and 65% of options trades in the United States, and applies data analytics to uncover insider trading and other strategies used to gain an unfair advantage. FINRA recently moved a key part of its technology infrastructure to AWS, adopting AWS Lambda serverless computing to make data validation more efficient. The system performs up to 500 billion validations each day, adjusting to variations in processing demand over time, which can double or triple in response to market conditions that drive higher trading volumes. Startups such as Amenity, who uses state-of-the-art linguistic pattern matching techniques to unearth actionable data points from textual data, ranging from regulatory filings, news articles, research reports, and earnings call transcripts, uses AWS Lambda to perform complex NLP classifications. Moving to serverless NLP has reduced their cost of analysis by 90% and time of analysis by 95%. They also use AWS Glue for serverless ETL and has managed to bring down their costs by 50%. We are lucky to have one of our customers with us here today. Let's hear from Adam, who is a senior intelligence researcher at Bluefire AI, on how they used Amazon EMR to solve their data ops problem and reduce their computation time by 97%. Over to you, Adam.
Thank you for the quick introduction, Witom. This is Adam from Bluefire AI. I'm thrilled to be here today sharing you our recent use case and breakthrough with Amazon EMR. I'm functioning as a math guy in our shop, so please do excuse me for under-spoiling technicalities in this presentation with respect to Amazon EMR. A lot of computation possibilities is enabled in my journey with Amazon EMR. It is a very great product allowing non-technical research team to delve themselves into it. Nonetheless, this work wouldn't have been done smoothly without the great guidance and support from peers from AWS across multiple continents and regions. A big thank you to those who have been supporting and guiding us forward. I think it is best that I start by sharing who we are and what we do. This gives rise to the very specific challenge we face on a vast landscape of data and model. We have, of course, integrated Amazon EMR as a solution to explore further computationally intensive solution to our modeling and data works. Lastly, we'll wrap up the session with our future roadmap that is continuously evolving. In a nutshell, we built an intelligence engine which harvests vast channel of information and accurately monitors quote-unquote health status of every single security within an investment portfolio. This is just like putting a smartwatch on every single investment one has position on. The light or alert goes off whenever early signs of illness or worsening is detected. Likewise, the engine we built is a border surface dog. It sniffs through all suitcases of investments and barks when it smells something is off. Emmeline, our AI analyst, is built on top of our engine that is live servicing our clients. I found this expression well describing the overall data landscape our engine is built on. From top left, we have language model-driven pipelines, multiple NLP pipelines corresponding to multiple sources of data. Different language source of text-based information is sourced differently. Moving down to the middle left are what's referred as companies' fundamentals. Quarterly, semi-annual, and annual published reports are disclosing financial statements such as balance sheets, income statement, cash flow statement, and more. We also integrate market participants' perceptions and opinions at scale, as well as real-time profiling securities transactions characteristics. All information from all channels at different frequencies are tied at different observables under the umbrella of all publicly traded entities and are transformed and fed into different ML AI models. Behind the brain of Emerald, highly accurate predictions are made for investments' possible unforeseen future downturns. Our team, the researchers, data engineers, data scientists, hit the ground start our R&D cycle with individual EC2 VMs on building POCs and productionizing them. The common pattern starts from data engineers, data scientists, fetching external inputs through REST and database connection, establishing ETL pipeline streaming and flattening data into in-house data lake. Our data scientists, ML engineers, and researchers consume flattened tables, train, test, and validate models where the model output is again flattened in consumable format for client services. Last but not least, model outputs in client servicing form then gets rendered by UX and data scientists into a client-friendly format to be integrated into their workflow. This is indeed a very viable and agile approach. Always wonderful, with one small catch. The computation requirement grows as number of data channel, number of models, and number of entity and security coverage increases. A couple examples of bottleneck includes complex join and aggregation faces a dilemma: should it be executed on the database side, or should the raw data be transferred to computation instance for aggregation? Some efficiency are text at I/O. Some models are memory heavy, and we need to rethink task partitioning to fit the entire input universe into chunks to fit memory within a finite computing time. It invisibly favors engineers performing minimal resistant implementation. We are not fully exploring the full space of mathematical solutions. One last major thing is I would hope having a unified framework performing R&D, production servicing, and live diagnostics. If one point the client raises a question or concern, tracing through the stack from different databases without the cross-data source joining can eventually be cumbersome. It can be done, but will be painful for a small team. When addressing the bottleneck, it's not surprising that Spark, PySpark, is the first thing that comes to mind. I've seen and heard more live production servicing for Spark than its peers. Before the integration of Spark into Bluefire, we were at 10,000 plus entities covered with 45,000 traded securities data. Raw data volume sometimes went gigabytes if they were not compressed properly. PySpark has its advantage of providing the sugar-coating layer of cross-source joining through a unified API. Users can connect anywhere the PySpark SQL data frame with pairing, matching jar, and configurations. It provides better flexibility to how we flatten, pivot, nest structuring information into table-like storages. Nested structure for model training input, where each cell can be a list to provide its benefit in diagnostic stage and model selection works. It has its advantage in data storage format, in particular, my favorite partition and compress Parquet. It also adds great flexibility to non-Spark model builders, given it has code candies integrating native Python, TensorFlow, and other C++ redistributable well. My experience and internal communication slogan is, it only takes about 5 extra lines of code to productionize a locally written model with a .inference API. But if that is so easy, why AWS specifically? Spark Cluster has its overhead to non-data ops audiences like me. Being a startup, our talents and flexibilities may be boundless, but our time and resources are not. Traditional Spark clusters that I have experience with tend to come with a data ops team that are lifelong career secured. They process very domain-specific Hadoop HFS Spark configuration and knowing the hardware provisioning how-tos. Me being a math nerd, I happen to know how to code, but certain things are beyond my reach. Hardware and resource provisioning, as well as edge node and user access, is beyond my knowledge foundation. Meanwhile, just like we do not know what we do not know, a cluster normally has 2 to 3 types of nodes. Some are job orchestration, some are work aggregation, some perform storage, some are computing specific. This adds an additional 3 degrees of freedom and 0 linear relation to find a solution for. My only known minimizing objective is don't sink the bill. Turns out, a bulk puzzle is already solved in the AWS. With this kind of guidance and help, we have our phase 1 EMR cluster established. In a nutshell, half of the problem is currently resolved, as Amazon EMR also is shipped with EMR FS. The AWS proprietary cluster-friendly version HFS that is backed and stored against S3 bucket. A simple solo master node and minimally 1 core node cluster is established without the need of providing all configuration details. Everyday surges in computation need are handled by task node scaling policies. Almost all legacy external sources, ETLs, can be streamed into EMR FS through PySpark. We do not have to estimate ahead of time how many nodes we need. Let it scale as it needs to, if it's not drifted to Ethernet. It is worth mentioning one may have different setting of task nodes, that lesser nodes are provisionable at higher spot instance price, more can be provisioned at lower price. That brings down another quarter of the questions remaining. All that remains for me is to execute and understand is the Amazon EMR web portal. Through quick experiments and following online demos, I was ready to get going. In this design, pre-existing data sources remain as is and are gradually migrating to S3-based solution. Whenever you have new fancier toy, all the Hot Wheels you have been playing would become legacy. I refer pre-existing databases as legacy sources in this exhibition. In an everyday workflow, all ETLs, including model inferencing tasks, are submitted to master node as a Spark step or through Spark Submit. A multi-step pipeline can be orchestrated and monitored easily with Apache Airflow, which AWS also supports. This change in R&D and production ETL is orthogonal to other components of our overall architecture. Ingestion codes and logics are mostly ported or remain unchanged. Output is backward compatibility exported as before databases. Flexible framework with modular changes in our use case it is. Here's a recap of what we have achieved from a hardware architecture perspective. We now sit on a cost-efficient, nearly infinitely scalable data processing framework. It is worth mentioning that it is not uncommon that I build prototyping code in EMR serverless notebook. We promote the logic into production ETLs by first encapsulating them into a Python source file, and then deploy as the same. S3 became the one place where data and model weight are stored, while allowing fine-grained control over prod data produced only by prod cluster, which research sites should have at most read access, through dev or UAT cluster that ad hoc investigation or model run task does not interfere with any production-related computation resources. I refer to it as a multi-user, multi-functioning consistency. Is that all? Of course not. We also have great computation speed improvement. One quick example I can mention is building full historical model output. In my pricey local setting, to compute least squares over 61.7 million rolling series, this takes up about 35 hours, 29,400 per minute with vectorized solution. The actual solver is able to solve in 16,384 batch size, and result is attained in less than 5 seconds, but much more throttling is raised from disk to memory, memory to GPU, GPU back to memory, and memory back to disk bandwidth that I have weaker capabilities to optimize. In comparison, a cluster can complete that same computation in less than 45 minutes. Spark's partitioning over Amazon EMR over EMR FS seemingly brings a great boost in efficiency, despite the fact that task nodes are much smaller, solving over a batch size of 1024. In terms of cost, the cost of my local setup is expensive and only for one person. However, the EMR cluster run took less than $20 for that heavy lifting to be done. Here, we have a glimpse of the power of the Amazon EMR. Also, at the end of the day, we seek productionizing everything in a replicable way. Day-to-day operations over UI can be overwhelming to DevOps or audiences that don't need the UI detail. The cluster configuration is easily recoded into a YAML template with rich AWS documentation. We have achieved creating redeployable hardware configuration from redeployable code. Here we skip the DevOps overhead mentioned earlier. First on our future roadmap is having different task nodes being provisioned for different tasks. NLP models may need larger instances as models tend to be deep. Quant models often involve root solving and can be done on smaller instances. The second one relates to the auxiliary core node. We are not really using HDFS, so the core node is barely used. Any penny spare allows us to hit our goal sooner. This is all to minimize underutilization nodes to zero. Serverless EMR is indeed the next one we are exploring. Last but not least, there are odd scenarios where CloudFormation provision resources need a little kick from the EMR UI to spin up upright. This is a minor point for me to fill up this page. Thanks for your attention. Back to you, Tom.
Thanks, Adam, for sharing your journey with us today. It was very insightful. Let's move on. In the digital assets and blockchain space, we see cryptocurrency exchanges leveraging AWS services for real-time exchange analytics. Exchange analytics enables them to get full insight into everything happening across the exchange. Coinbase, a digital currency wallet and exchange service based in San Francisco, and the largest consumer Bitcoin wallet in the world, uses Amazon Kinesis to ingest their operational analytics data in real time, which is then sent to their analytics engine for searching, querying, and finding trends from that data. They have also integrated the Insight pipeline with Amazon CloudTrail logs, which enables them to be alerted whenever a security group or network access control list is modified, thus strengthening their security posture. In the RegTech space, having an AWS data lake makes it easy to collect, store, and analyze data, while providing data lineage and auditability and enabling compliance with procedures such as Know Your Customer and regulations such as anti-money laundering and consolidated audit trail. Industry leaders such as AxiomSL, now known as Adenza, uses Amazon Redshift for running complex online analytical processing workloads for generating regulatory reports for their customers. In addition, Amazon Redshift Spectrum enables AxiomSL's flexible architecture to process increasing client workloads and meet ever-tightening SLAs. Using Amazon Redshift Spectrum, they can efficiently query and retrieve structured and semi-structured data from files in Amazon S3 without having to load the data into Amazon Redshift tables. In the wealth management space, we see companies like Clio, whose chatbot allows users to interact with their finances using Amazon Redshift and Amazon SageMaker batch transform to drive customer segmentation. Their analytics database is a Redshift cluster, which is updated frequently from their primary database. So they simply extract data to S3, call SageMaker batch transform on it, and re-import it into Redshift. The results of the model can then be used for visualizations, insight, or applications. We have seen companies like Robinhood, who uses AWS to operate its online business, deliver and update its mobile trading app, securely store customer information and trading data, and perform business analytics, all with just 2 DevOps people. They also use Amazon Redshift for their analytics use cases, such as identifying fraud or fighting money laundering. Storing and analyzing customer data in an AWS data lake enables fintechs to mine deeper customer insights, recommend tailored products and services, and create a personalized and enhanced digital finance experience for customers. We see a growing trend wherein customers are moving towards customer 360 knowledge-based solutions. Now, what do I mean by that? Organizations build and deploy large-scale data platforms like data lakes, data warehouses, and lakehouses to capture and analyze a holistic view of their customer's journey. The objective of such a data platform is to understand customer behavior patterns that influence satisfaction and drive more engagement. Applications today capture each point of contact with the customer, but the data is spread across different locations, such as external partners, outsourced SaaS like chatbots or call centers, on-premises systems, or public clouds like Google Analytics, with little or no links between the data captured. Therefore, the challenge is to connect these disparate data sources as your customer navigates from initial contact to their current state in their journey. You need a 360-degree view of your customer through a knowledge base containing key attributes of their journey and links pointing to detailed data. This knowledge base must be flexible, agile, and extensible to support new data patterns as your data landscape evolves. Amazon Neptune is a purpose-built graph database to store connected data patterns, which you can use to build a customer 360 view by capturing data from a customer journey in near real time. The connected data solution can serve business insights to your customer service representatives, assist with new sales, provide recommendations for customers, power customer 360 dashboards, or serve as a data repository to perform machine learning-based analytics. In the lending and credit space, an AWS data lake makes it easy to aggregate and analyze a variety of data types to conduct high-quality risk profiling in the underwriting process. Complemented with AWS AI/ML capabilities, fintechs can automate and build an effective credit decisioning workflow. For example, data can be captured from lenders' mobile apps, ingested real-time into an Amazon EMR cluster, which can then be used to trigger ML algorithms that will determine an applicant's credit score. CreditVidya, a startup headquartered in India, is using their underwriting technology to open the country's loans market to over 250 million financially excluded citizens. To determine creditworthiness, CreditVidya's AI and ML platform Medhas leverages payment data, financial behavioral data, and device data stored on smartphones to help determine loan applicants' ability and intent to repay loans. Since working with CreditVidya, lending partners, which include 55 leading banks and non-banking financial institutions in India, have seen loan approval rates increase by 25% and delinquency rates decrease by 33%. Today, the Medhas platform has about 250 terabytes of structured and unstructured data held in Amazon RDS, Amazon DynamoDB, and Amazon S3. Data is stored in Amazon S3 with metadata from that dataset held in Amazon DynamoDB. When querying large data sets, the business first queries the Amazon DynamoDB table, gets a list of objects to be fetched from Amazon S3. They have also started using Amazon S3 and AWS Glue to build data lakes. They plan to use the data lakes to analyze performance of its partners' loans by demographics, occupation, or geographical location. The startup expects its data lake to hold approximately 500 terabytes of data over the next 2 years. With that out of the way, let's take a slight detour to learn a bit about Amazon S3, the de facto storage service powering most data lakes in the cloud, and few higher-level services in the AI/ML space which our customers are using. Exponential growth of data means customers need a data architecture to ensure they can use their data cost-effectively and turn data into value. They also need to address a variety of workloads such as data lake, backup, and archive. it's not easy to strike the balance between cost and retrieval speed. Amazon S3 is the largest and most performant, secure, and feature-rich object storage service. With Amazon S3, organizations of all sizes, industries can store any amount of data for any use case, including data lakes, analytics applications, archive, backup and restore, and disaster recovery. Built upon 16 years of innovation, S3 is the best place to build data lakes, and it offers the lowest cost storage for archive data. At reInvent, S3 launched a new archive instant access capability so customers can turn their archive data into work with ease. Take advantage of the most suitable storage class for use case. You can also make use of new features like S3 Object Lambda and multi-region access points. As we are all aware, AI/ML is first-class citizen in today's technology landscape. While most companies around the world and across all industries want to add AI capabilities to their applications and processes, they don't always have the skills or time to develop their own ML models. AWS offers the broadest and most capable set of AI services that can easily add intelligence to your business application or workflow. For example, you can use Amazon Textract to process scanned documents for eKYC purposes or filling out applications, or Amazon Comprehend for sentiment analysis of financial news. Often, the first step in your AI/ML journey is to identify the use case that requires an AI/ML solution. We often work with our customers to identify the same. Once you have identified the use case, we can help you with various resources such as reference architectures, GitHub samples, or specialist conversations to develop your solution. Do feel free to reach out to us regarding the same. Before I let you go, we really value your feedback, so we would really appreciate if you took some time to fill in the survey at the end of the session so that we can continue to improve our events to better cater to your needs. We encourage you to get engaged with our training and certification content today. Skill Builder is our online learning center that makes it easier for anyone, from beginners to experienced professionals, to build AWS cloud skills. We offer 500 plus free digital courses that can help you and your team build new cloud skills and learn about the latest services when and where it's convenient in up to 16 languages. Scan one or both of the QR codes on the screen to get started with your cloud skill training and certifications. Thanks again to everyone who watched our segment today and looking to connect further as you go along on your data and analytics journey on AWS. Wishing you a great summit experience for the rest of the day. Take care.